So next is state of a system and thermodynamic variables. Okay, so the state of a system is very common term in thermodynamics. Okay, so what is thermodynamic state of a system? So the state of a system is the condition of a system at a specific time that is fully described by a set of experimentally measurable quantities. So suppose you have a system, okay, and you want to fully describe its condition, okay, at a specific time. So suppose you are observing a suppose engine of a car and you want to describe completely its condition at a specific time. Then you will need a set of experimentally measurable quantities. With the help of those experimentally measurable quantities, you can completely describe the condition of the system at a specific time. So that condition which is fully described is called the thermodynamic state of a system, or simply state of a system. And this set of experimentally measurable quantities are called thermodynamic variables or variables of state. So we can define the thermodynamic variables or variables state in the following way, that a set of these are the set of experimentally measurable quantities of a system by which its physical condition, that the system's physical condition, can be specified. Okay, so we already know that to fully describe or specify the condition of a system, we need a set of experimentally measurable quantities, or to describe the state of a system, we need a set of experimentally measurable quantities. Those experimentally measurable quantities are called thermodynamic variables. And we can define the thermodynamic variables as a set of experimentally measurable quantities of a system by which we can specify its physical condition or its state. Okay. Now, what are some examples of these thermodynamic variables or variable of state? So, the pressure, temperature, volume, surface area, electric field, mass, surface tension, okay, electric charge. These are some examples of these thermodynamic variables. Now, there are two types of thermodynamic variables. So, what are those? The two types are the intensive variables and the extensive variables. So, at first, what is intensive variables? So, the variables of a system in a given state that are independent of its mass or the number of particles that are present in the system are called intensive variables. Okay. An example of intensive variables are pressure, temperature, electric field, etc. So, these variables are independent of the mass or the number of particles present in the system. So, they don't depend on the how much matter is there in the system or how many particles are there in the system. Okay. So, one example can be like this. Suppose here you have some water in a container and its suppose temperature is suppose 30 degrees centigrade. Okay. Then suppose this is the, so it will form a system. Okay. Then you have another system. There is another container in which again there is some water. Okay. And its suppose temperature is, suppose this is T1 and then its temperature is 40 degrees centigrade. Okay. Now if these two waters are added, then they will form a new system, a third system. Okay, third system. Okay, now this temperature being intensive variables, these intensive variables are not additive. Okay, are not additive. It also means that they don't depend on the mass or the number of particles in this system. So, if we add these two systems, they will form a new system, and you see the temperature of the newly formed system will not be 30 degree plus 40 degree equals to 70 degree centigrade. It will not be equals to 70 degree centigrade. So the temperature is such a variable of this system that if two systems are added, then the newly formed system, in case of newly formed system, the temperature will not be the addition or sum of the temperatures of this individual system. Okay. So similarly, in case of pressure also, if you add two gaseous system, then for the newly formed system, the pressure will not be addition of this initial pressures of the individual system. Same goes for electric field. So the intensive variables are not additive. That is, they don't depend on the mass or number of particles. So the temperature or the pressure or the electric field does not depend whether the system has a greater mass or smaller mass, or if the number of particles is very large or very small. So in contrast to intensive variables, what is extensive variables? Okay. So here the variables of a system will depend on, here the variables did not depend on the mass or the number of particles. Here they will depend on the mass or number of particles of the system, or we can say that these variables are proportional to mass or the number of particles that are present in a system. Okay. And some examples of the extensive variables are the volume, length, area, charge, etc. So it is evident that if the number of number of particles in a system is more, then the volume occupied by the particles will be more. Okay. So volume is proportional to number of particles or the mass. Similarly, same goes for the length, area, also charge. Okay. So the extensive variables are additive. Okay. So suppose we have water in a container and its volume is suppose V1. Okay, it is forming the first system. Then we have another system. Okay, second system. Again, water in a container, its volume is V2. Now, if we join these two systems, then we will have the third system, newly formed system. And what will be volume of this system? So you see V is V1 plus V2. So here you see the volume being an extensive variable depends on mass or the number of particles. If the number of particles or the mass of the water is more, then the volume will be more and it is additive. Okay. So every extensive variable is additive. Okay.